Hi, my name is Jim Wickenheiser. I'm the COO of SiliconCore, and we're coming to you from ISE 2025. We're pretty excited to be here. We have our new Enlighten brand COB. First time that we're exhibiting this, first time to the market.
So what's special about it?
So there's a couple things that's special about this. So first of all, it has our Common Cathode IQ driver chip. We're the only one in the industry that makes our own driver chip. And we were the first to market with Common Cathode back in 2011. And then we've enhanced that driver chip just this year with our IQ technology. That IQ technology allows us to run brighter, cooler, and with ultra low power. So very, very low power. So I mean, some of the stats on this are actually kind of mind-boggling. So like this unit right here is running at 600, well, it's running a little over 600 nits here, but when it's running at 600 nits, it's running at about 365 watts. So this is a couple of light bulbs, right? And you get this beautiful display. So
Couple of light bulbs.
yeah, a couple of light bulbs, right? So not LED light bulbs, but traditional incandescent bulbs, right? So it's extremely low power. So you're talking about a unit like this can run off of a single outlet, and so it still have plenty of overhead to run, PC, multiple laptops, all that.
And if you want to run like four of them together as a 4K setup,
Yeah.
then it's just 8 light bulbs.
That's exactly right. So it's actually 4 cables, right? Because so this is a 1080p setup. This is our 0.93, and so 4 of these makes a 4K. And so even that, you're still talking about running it off of a single circuit instead of having to drop your own new power into there. And and they're very thin. They mount right onto the wall. So in the U.S., there's something called ADA compliance, which is for disabled folks. And basically, you have to be with a very small distance from the wall. Otherwise, it becomes a bumping hazard. And this is well within those limits. So.
And when you talk about COB,
Yes.
what's been your consideration to get to there? And is it special to be able to do this?
Very good question. So one of the big issues with COB traditionally has been uniformity. So when you have a white field or a blue sky or whatever, you can see the different panels very easily. And there's a lot of effort that goes into getting the COB correct with the uniformity and with high brightness, because most COB that you'll see out there really struggles with its uniformity. I mean, look at this blue field, it's like, it's perfect, right? And so that's not very common. The other thing that's not common is, basically they're very, very low brightness. And so this one is capable of going 1200 nits out of the box. We have configurations of this that could go up to 2000 nits if that's what you need. But most of them are capped out at like 600, 800 nits, so they can't go very bright. And so we were waiting until, and we've been playing around with COB for a very, very long time. And we've just now gotten it to the point where we're happy with it. So we have very high standards. And so we weren't going to release it until we could bring it with SiliconCore quality.
And what does it stand for, the COB?
Chip on board. So the difference between kind of a traditional LED and COB is that traditional LED will actually take LED surface mount packages and mount those on the board. And with chip on board, they're taking the actual LED crystals and mounting those directly on the board. And so there's no LED packaging at all. The module itself becomes the package. And so because of that, they can't do traditional bin mixing like they normally do with a packaged LED. That's why the uniformity is so difficult to achieve, is because mixing an LED crystal is extremely difficult. And so there are all kinds of mixing techniques that we've had to come up with in order to achieve this kind of uniformity. So, and it has to do with how you do the pick and place of the crystals, as opposed to literally having the packages in a mixing bin which is where bin mixing comes from. And you can't do that with a LED crystal because it'll crack, it'll break. So, yeah.
So pick and place.
Yeah. So basically, it's taking either the S&B package or it's taking the crystal, and they literally pick it out of, well, there's different ways of doing it. There's tape and reel, but anyway, and there's blue tape. But basically, it's taking the device, it's picking it up and placing it on the PCB. And so then from there, it gets soldered. And then the other thing that we do that is very, very different for both our SMD products and our COB is that we put down a black layer on the PCB that does not cover the LEDs. And then we put an optical grade clear coating on top of that. Most other people are doing a black layer, a black coating across the whole LEDs. So it makes it darker, but it does help with their uniformity. So credit where credit is due, that blackness reduces the brightness, but it does help their uniformity, but it impacts their power as well. So that you have to go more power to go as bright. And so that's part of our secret sauce is we're doing that black first. So.
And how do you not cover the LEDs?
That's proprietary. So that's a patented technology that is...
because it's very small stuff,
It
right?
is very small stuff, and it's very difficult to do.
And it needs to be precise?
Absolutely, it needs to be precise. So the process on that is pretty well guarded.
And you need to be able to manage the yields.
Yes, that's right.
And quality control.
Right.
Check that you do everything right.
Yeah, because you're absolutely right. So the yield on COB is typically very low, and so our yield is actually quite high. So and part of that is some of our secret sauce, but part of that is that we pay a lot of attention to the LED bins that we get. So, and when you talk about LED bins, you're talking about what nanometer for each color you specify. So for an LED bin, you could say, you want a certain nanometer and then plus minus on top of that, right? And the tighter you bin that, the tighter the nanometers that you allow for, the more precise and the better uniformity you're going to get. But it also makes it more expensive. And so we go with very, very tight bins, whereas most people are going with very loose bins, and that makes it much cheaper, but their uniformity suffers, their image quality suffers. So that's part of what we do.
How good is your uniformity?
So, I mean, you can look at it right here. Like, this is a great image that came up, right? So it's just like, it's very difficult to see the different modules on here. It's very difficult to see any kind of change in color across here. We're putting up white, which is death to most LEDs. But, the white looks
like
great.
it's one panel came out of the fab.
That's exactly what it's supposed to be.
It's very hard to see the seams.
That's exactly the point, and that's exactly showing what kind of great uniformity we have. Because typically you'll see color differences, color shift, color differences between the different panels, but with ours, you just don't.
So you have to work with the player, the engine, the guys who do the rendering?
Yes. So content is one of those things that it's really like garbage in, garbage out, right? So if you have low quality content, it doesn't matter how great your display is, it's not gonna look great, right? Like, terrible content is never gonna look good. But if you have good, really high quality 10-bit content, and people who understand how to make the content, it's gonna look fantastic. Now, look, any image that we put up there, it's going to look as good as it possibly can. But if you have images that people understand how to work with LED, then it just pops, right? It really becomes a visceral experience when you see the image in the display.
Like, I don't know if I can capture the quality that people can see with their eyes, but you try to reach a certain level, right? Where people are saying, oh yeah, this is just kind of like a perfect experience?
Yeah. So a lot of this experience comes from our driver chip. So the really, really good image quality is the nice gray ramp reproduction that comes from our driver chip. So we have three major technologies that go into this. So we have our Common Cathode IQ, which I mentioned before. Lisa, which I sort of described. So the Lisa is actually the encapsulation. So, and I described how we did that earlier. The other is our ZAC technology. So that allows us to go with really, really high bit depth and get really, really good details in the dark areas. And so it's interesting, when we were starting the show, we had a content mix-up like 2 days ago where we had 8-bit content when we were supposed to have 10-bit content. So we got the content back in that was correct, and we were A-Bing the 8-bit versus the 10-bit, and there's sections of the image that just completely became visible with the 10-bit that weren't visible on the 8-bit. And again, that comes down to our driver chip being able to reproduce all those gray levels, and understanding how the content is supposed to work.
Where's the driver chip? Is it?
It's
how many
on the back of the PCB. So if we were to take out one of these modules on the back, you would see a SiliconCore driver chip. And again, that's proprietary to us.
How many modules are there?
Oh boy, I'd have to ask one of my techs.
Are the
so the module itself is about that big. So yeah, I'd have to ask.
And you can put together as many as you want.
That's right, completely modular. It'll go as large as you need it to go. This is a 1080p 0.93, but it could literally scale to any size that you want.
You can do smaller also, or you do?
We could. So you know. So we have a product that's out right now that's a 0.83. We'll have a 0.78 here shortly. And actually with this technology, we can definitely go to lower price points than we have in the past. And so some of these pixel pitches that were kind of out of people's budget even just a year ago are starting to come into their budget. So yeah, we're starting
even
to see
at the smaller even at the smaller millimeter dot pitch.
Yes, for us,
it will still be affordable.
Yeah, it's absolutely pushing that direction. So it's like all tech where it starts to get cheaper and cheaper, you know.
And what's the partnerships you have with the companies here at the ISE 2025?
Yeah. So one of our main partners. So we work with several different people for the Sendbox controller. So we work with ColorLight, we work with Novastar, and we also work with Megapixel. So we typically use ColorLight and Novastar for our kind of standard installs, but for things like virtual production and those that need very demanding performance and color, we go with Megapixel.
And then, for example, it could be Hollywood.
Absolutely. They go into Hollywood setups. They go to all kinds of virtual production setups.
You have some setups.
Yes, we do. Yeah, no, we.
So maybe there's some really cool movies or TV shows that people watch.
Yes.
There's your technology behind.
That yes, I absolutely know that there are some stuff that they've seen our stuff on, but we also have ODM partners that are doing this, and so some of them have been with them that we're not at liberty to say publicly, but yeah, you've definitely seen TV shows and movies that have been shot with our stuff.
And when you work with Megapixel, it gives also some more crazy ideas for huge setups, maybe?
Yeah, no, so typically people like
8K.
to do... Yeah, bigger than that. So typically with the Megapixel stuff, they're putting these on very large, what are called LED volumes, because they're huge. And they do an excellent job because they have a really large canvas. So, Megapixel is really, really good at being able to handle multiple inputs, keeping the color correct, and managing the large areas that the video goes on to.
Calibrating the whole thing.
Absolutely.
And how about your engine that you were talking about on each board?
Yeah.
How does it talk with the Megapixel system, or is there like some talk happening?
Oh yeah. There's definitely communication there. So basically, the way the architecture lays out is that you have a control box, and I'm going to be a little bit generic here, not just specific to Megapixel, because Megapixel actually runs a little bit different than the other controllers. But just in basic terms, there's a controller, and then something called a receive card that lives inside the display. So like each of these cabinets has something called a receive card in it, and Megapixel puts a lot of their processing power on their receive card. Other people don't put as much processing on the receive card. It's more of just kind of directionality, like making sure that signals go to the right place. But Megapixel does a lot of intensive processing on that receive card. So there's a receive card, and the receive card then talks to our driver chip. So our driver chip is kind of the last piece in the chain where it says, okay, here's the colors and the brightness that you need to achieve, and then we handle the part where we make sure that it looks correct. So.
And do you need to update the whole compatibility and the perfect transition between all the technologies? So can you support like 10-bit or?
Oh yeah. So we can actually support up to 16-bit. Now, no one has ever given us a 16-bit signal, so we internally still run at 16 to 22 bits internally, depending on how you want to calculate it. But yeah, in terms of a video signal, if someone were to provide us a 16-bit video signal, we could output it perfectly. And so typically people are feeding us 8 and 10-bit. There are some that are able to feed us a 12-bit, but that's the exception. So it's typically 8 to 10-bit.
And I see a powered by 7th Sense. Is
Yes.
that a partnership?
Yeah, so we are partnered with them at trade shows all the time. They have a great playout system. We're always happy to work with them. You know, we've got their stuff on our booth, and we've got some stuff on their booth. And yeah, they're really great guys that really know what they're doing on playout.
Is it player?
Yeah, it's a video player, and it's top of the line. You know, really. As far as I'm not a video player guy, so I don't want to overstate anything, but everything that when I watch them work, it looks like it's an easy interface, and they're able to do timelines very easily, very creative timelines, insertions, drop in and drop out of your timelines, and yeah, no, lots of easy to do cues. So, but again, that's not my area of expertise. So, but
Available now?
Yes, this is available now. Already shipping. So yeah, 0.9, and this is our 1.2. We also have a 1.5 and 0.78 coming soon.
And we do another video about your other setup right here.
Sounds great.
Which is called
All-in-one.
All-in-one.
Yep.
All right.